Order of operations are an important component of any middle school math class. This video will describe how Bootstrap introduces the concept using an innovative method called the circles of evaluation. These circles are a crucial ingredient for teaching orders of operation and function composition, and they also form the basis for the programming languages students will be learning. The core problem is that orders of operation are actually a literacy skill as opposed to a computational one. The goal here is for students to read an arithmetic expression like 4 plus 5 times 6 minus 1 and to be able to parse which expressions come first. As math teachers, we often assess student understanding by asking them to compute an answer. Unfortunately, computation is a terrible way to evaluate literacy. If a student gets the right answer from computing 2 plus 2 times 2, we still have no idea if that student knows which operation comes first. Likewise, a student that gets the wrong answer for 3 times 9 minus 4 might actually have made a mistake in multiplying, but could still have gotten the order right. To evaluate a literacy skill, we need to use a literacy tool, and that's exactly what the circle of evaluation is. We introduce the circles of evaluation by writing a jumble of numbers in a circle and asking them if the symbols alone make it obvious what needs to be done. Once they realize that the symbols aren't enough, we add a grammar. Every circle of evaluation has only one function, and the inputs to that function are read left to right. For expressions that have multiple functions, circles are nested one inside the other. As teachers, we're not changing the way we present the rules for this ordering, but by shifting the assessment from give me an answer to diagram the arithmetic sentence, we also shift the focus of the student learning to where it needs to be. Circles of evaluation make a terrific assessment or homework tool and can be used with order of operations sample problems in any math book. Note that the circles of evaluation also allow us to start talking about functions without having to introduce function notation. Students can even start thinking about function machines at this stage, using the arithmetic operations that they feel comfortable with. When plus and minus are replaced with f and g, the circles of evaluation provide a seamless transition into function composition. The circles of evaluation are also used to introduce the syntax of the programming language. Picture a small ant who's trying to visit every symbol in a circle of evaluation. First, the ant has to enter the circle, crossing over the curved boundary. That boundary gives us the first symbol in our program, an open parenthesis. Then the ant visits the function on the top, where it finds the division symbol, and then the ant crawls from the left to the right, starting with the number 351. But on the right, there's another circle. The ant has to crawl inside that one. The ant repeats the process, visiting the top of the inner circle and moving from left to right. And when it has visited everything inside the circle, it has to cross the right-hand edge to escape, so we add the closed parenthesis. Don't forget that it also has to cross through the outer circle as well, so you'll need another closed parenthesis. Have your students practice converting expressions from math into circles of evaluation, and then from circles into code. Later on, when your students start writing more code, they can fall back on the circles of evaluation as a tool for thinking things through before their hands ever touch the keyboard. If you have a student who needs help matching their parentheses on the computer, have them draw the circles of evaluation instead. This lets teachers focus on students' thinking instead of on students' code.